Hello, everyone. We're starting a new unit today. We are going to be talking about exploring quadrilaterals. The first question is, what is a quadrilateral? It is a four-sided polygon. To recognize what we're going to be doing is recognizing and applying the properties of parallelograms and applying the conditions that ensure a quadrilateral is a parallelogram. So you're going to be asked, is this quadrilateral a parallelogram? And you'll have to tell me yes or no. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So right here, I have parallelogram MATH, spells math. When we name a quadrilateral, we use the letters just like we would a triangle. But we actually have this cool symbol that looks like this. Looks like a parallelogram. So if we're naming this, we would say this symbol, just like we would with a triangle. We would normally put a triangle. We would say MATH. You just go around the shape in order. So you could say MATH. You could also have one MHTA. You cannot say MTHA. You can't go all zigzag through the parallelogram. You have to go around in a circle. Okay. The vertices are the corners. So our three corners are M, A, T, and H. We also have to think about our opposite sides. So MH is opposite of AT. And then likewise, we also have MA and HT that are opposite sides. Opposite angles are the angles directly diagonal from each other. So M and angle T. And then we also have angle H and angle A are opposite each other. Consecutive angles are angles that are one right after another. So M and H. Oh, sorry. Just like in class, I keep yawning. Angle M and angle H would be consecutive. You could also say M and A are consecutive. H and T are consecutive. So any angles that are next to each other. T and A. Okay, and that's about it. Our diagonals connect the opposite angles. So I can draw diagonals here from M to T. So, and I don't know why I dotted this. It can be it's a solid line. MT is one diagonal, and our other diagonal would be from H to A. Now we're going to talk a lot about diagonals in this unit. So like we said, parallelograms have opposite sides that are parallel. So I'm just going to go ahead and label these two opposite sides as parallel. Same with these two. Okay. Now let's talk about some of the theorems. Now I'm going to attach these notes onto Classroom. You do not have to fill them out or anything, but I'm just putting it on there as an option if you are someone who likes to fill out notes. You could be doing this in a notebook, but if you're someone who has a printer at home, then you can print these out. So I'm giving you that option, but you do not need to send it to me or anything like that. This is just me giving you the typical notes I would in class. So the first things you should know about parallelograms is that opposite sides of a parallelogram are congruent. So now I'm going to flip back to this picture. Oops, forgot I'm on two sets of papers. Opposite sides are congruent. So that means these are congruent and these are congruent. Okay. Opposite angles of a parallelogram are congruent as well. So M and T are opposite. Those are congruent. H and A are opposite. Those are congruent. Consecutive angles in a parallelogram are supplementary. That means they add to 180 degrees. The diagonals of a parallelogram bisect each other. Okay, so that means if these bisect each other, then this is basically a midpoint for both of them. So that's those two pieces are equal. These two pieces are equal. And I'm actually going to use more because I already did label some sides in here. I'm going to use more tick marks. So these two sides are equal. These two sides are equal. So basically the diagonals are cutting each other in half. There is one other point I wanted to make on here, and that's that all angles in a parallelogram add to 360. All of these angles add to 360. All right, let's do an example. Find all missing measures in parallelogram math. So let me go ahead and start labeling things. I know that these opposite sides are equal. So 15 and x should be the same. So x should be 15 because opposite sides are congruent. Y, now looking at y, these two angles should be equal. So if that's 55, this should be 55 degrees because opposite angles are congruent. Lastly, we have W. W's opposite angle is not there. However, I do know these two angles are equal, so I can label that, but that doesn't give me any information. What they did tell me in theorem 6-3 is that these two are supplementary. That means they add to 180. So all I have to do is 180 minus 55. Okay, you get 125. So W is 125 degrees, and that's because consecutive angles, these are consecutive angles, are supplementary. Okay, last thing on this one is if we draw diagonals, I'm going to use a different marker for this so you can see it good. If we draw our own diagonals in, so I'm drawing my diagonals in orange. If we draw our own diagonals in and we label this middle B, which segments would be congruent? So like I labeled in my last picture, these would be congruent and these would be congruent. So they just want you to say here that MB would have to be congruent to the other half, BT, and this half HB would have to be congruent to this half, BA. Okay. So this is parallelograms. It's part 1 of the quadrilaterals unit. We will get to different types of shapes and different types of quadrilaterals in the coming classes. Okay. Hope everyone has a great Friday. Have a good one.